today I'm going to talk to you about building and running microservices in the cloud without really having to set up or manage any servers to do this, right? And this might sound kind of impossible, right? Microservices without servers, because surely if you have some code and you want to run it in the cloud, then you have to set up and manage those environments. So I'm going to show you a new approach using what they call serverless cloud platforms that allow you to do just that. And in the second half of this talk, I'm actually going to be doing a live demo of building a real application using one of these service platforms to give you the kind of tools and techniques to go away and do this yourself. Now, at this point, you might be thinking, as well as this sounding impossible, right? Microservices without servers. You might also think that it sounds unnecessary. You might think, well, why would you want to take my servers away from me? I've got them set up just how I want them, and I can log in over SSH to configure my application and copy my WAR file in, right? Why would you want to take my servers away from me? Well, the reason is this, right? Servers are killing your productivity, and you might not realize it yet, but trust me, it's true. And by the end of the talk, I think you're going to agree with me. You're going to want to go back to work, gather up all of those Linux machines that you have, set them on fire, and be free of the tyranny of looking after infrastructure forever, right? I am convinced that servers are one of the worst things that's ever happened to software developers, right? So why am I so convinced that servers kill your productivity? Well, let me tell you a story to give you an understanding of why I feel so passionately about this. Right? Imagine you've had a new idea for a new product or service or API that you think is going to be the next kind of billion-dollar unicorn startup, and you've got this great idea, and so you spend the next couple of weeks furiously coding away in your spare time to kind of turn it into reality. And you finish the code, and then you think, okay, I've got the code, I've got some users who want to try it out. All I have to do next is I have to provision some servers. I put my code on the server. I can give people the address. They can start to use it. I'll soon be on the way to being the next Mark Zuckerberg. Except as soon as you provision that first environment, suddenly you have all of these extra tasks to take care of, right? You have to install the operating system, keep that updated, get all your code on, the application middleware, the database services, all those kind of features. You have to think about security and encryption and firewalls and all those kind of rules. And then you have to think about capacity planning, right? How much memory and RAM and CPU does my server need to be able to cope with so many requests a second that might happen in 3 or 6 months' time? And as hopefully your application grows, right, you have to think about scaling. And for most people, that means more servers, right? Maybe I'll provision more environments, and I can run them in a cluster, and I can worry about scaling and replication and fallover. And suddenly you find yourself, as a developer, spending all of your time managing these environments. And I think as developers today, we're being held hostage by our infrastructure, right? I want to spend time coding on my keyboard. I spend all my time logged into some Linux machine, twiddling around with kernel parameters to try and fix my application. And all I want to do is have a nice, easy way to run my code. I'm not really a kind of infrastructure engineer. Now, you might think at this point, well, hold on, James, right? Wasn't the cloud supposed to fix all of this? I've always been told that I just need to put my applications in the cloud, build cloud-native architectures, and all of my infrastructure challenges go away. And I think we get sold this utopian vision, right? That cloud computing allows you to treat, computing resource just like electricity or gas or water, like a utility. You can provision on demand, use as much as you want, and then you only pay for the bits that you use. But for many of us who use the cloud today, what the cloud turns out to be is renting virtual machines by the hour in someone else's data center. So maybe I don't have to physically buy the server and kind of plug it in anymore, but I still have to manage everything from the operating system up. And this is not really how I think about a utility model for computing. Right? I think if you took this same model of infrastructure as a service and applied it to a real utility like electricity, what you would get is a company that when you rang them up to get connected to the grid said, well, we can't just give you power, but we can bring around loads of generators and we'll install them in your backyard and we'll connect them together and we'll give you power that way. And you think, maybe this doesn't sound so bad, I still get power, right? But then when they've come around and they've set up all these generators, you have to maintain them, right? I have to put the petrol in, I have to keep them oiled to keep them working. And this is just like VMs, right? When they're set up, they're my responsibility. So you have this kind of generators as a service thing. And then one of the other challenges you suddenly realize is that once these generators are up and running, they're generating power 24 hours a day, even if I'm not using it. And it's the same with VMs, right? And if your application is idle, you're still kind of paying by the hour. And then the other challenge is, right, the first question that this company, Generators as a Service, asks you when you ring up is, OK, so how much electricity might you need in 12 months or time or 3 months so we can bring around enough kind of equipment so you have enough capacity, right? You need to do your capacity planning. And it's very difficult to answer those kind of questions. Right? I'm not a wizard. I can't see into the future. I don't know how much load I might need in 3 weeks or 2 weeks' time. And so what most people do is they over-provision, right? You ask for extra capacity so you can cope with kind of intermittent load. And it's the same with VMs, right? You have to decide up front how much disk space and memory and CPU you need on a fixed capacity, and how much you need to add. You need to decide this up front, and it's kind of quite difficult to do. I don't really want to do that. I just want the power. I just want the kind of computing resource. And it's not just time that you waste, I think, managing all of these environments, right? All these extra generators that you don't even use or VMs. It's also money. So Google did a big study in July 2013 looking at utilization rates on some of their bigger clusters, right? These were clusters with 20, 30,000 machines in. And what they found was that the average utilization rate was just 20 to 40%. So 60 to 80% of the time, those applications running on those servers are sat there idle, waiting for requests to come in. If you're renting VMs by the hour in some cloud data center, you probably have similar utilization rates, which means that you're spending the majority of money on getting no return. And again, if this is supposed to be a utility model for computing, right, this is like as if you had a water company that when they install the tap in your house, like you had to have it running 24 hours a day just to go and get a glass of water in the middle of the night. And that's not really, again, what I think about a kind of utility model. So what can we do, right? Hopefully I've convinced you now, you agree with me that servers are killing your productivity and you're ready to set them all on fire. But you still need a way to run your code, right, and run your code in the cloud. So, how can we do this without getting dragged into managing all these environments? And today I want to kind of introduce you to a new category of running code in the cloud, new kind of type of platform that they call serverless platforms. And they've been around for about 2 years and they're kind of growing in popularity. And they're built as a kind of next-generation cloud computing service that really, really allows you, for the first time, to treat computing resource like this utility model. Now, the first thing to state here is that although they're called serverless platforms, of course, your code's going to be running on a server somewhere. It's not going to run in the sky on a real cloud. It's going to run in some virtualized Linux environment. But the reason they're called serverless platforms is that from the developer's point of view, from your point of view, you have absolutely no interaction with the underlying platform. All you do is work on your code, you push it into the platform takes care of everything else. So if you've heard about serverless platforms now, maybe in the past couple of years, or maybe you've tried something like AWS Lambda or Azure Functions or OpenWhisk, you might be a bit confused about why this is that interesting, right? It'll say things like, it runs your code in response to events. It manages your resources. Allows you to build event-driven applications. And you might think that doesn't sound particularly revolutionary. But serverless is different. I think serverless is revolutionary for a couple of reasons. The first is that it shrinks the unit of deployment. So rather than having to deploy your application as an entire VM image with all of your code and services and databases all baked in, or even as a monolithic deployment package with loads of classes and XML configuration and all that kind of stuff, serverless platforms allow you to deploy just your microservices, your functions, individual functions that you want to run to process individual events. And you push the code directly into the platform. And then when a request comes in over the API, the platform will spin up the environment, spin up your code on demand in milliseconds to process that request for every request that comes in, right? You don't have to think about setting up the environment, setting up the servers. You just push your code in, and the platform is responsible for everything else. And all you have to do is finish your code, add a little interface, which is kind of the hook into your source for the platform, and the platform takes care of everything. And what happens with serverless platforms is, as I said, rather than having your microservices sat there waiting for requests to come in, they get spun up on demand for every single request. So what happens with one of these platforms, right? If your service, your code has been executed, it's processing a request, and before it's finished, another request comes in parallel. Well, with serverless platforms, the scaling is the platform's responsibility, right? Provided your functions are stateless, what happens is it spins up, again, in milliseconds, another instance of your service to process each individual request that comes in. So rather than having to think about capacity planning and like how much memory and CPU and disk space does this VM need to process this many requests, right? It's the platform's responsibility. It scales horizontally to cope with kind of almost infinite load. And as well as kind of scaling up, serverless platforms also kind of scale down because I said your code's only running when you're processing requests. So most of the time, if your application's idle, none of your services are actually running on the platform. And this is really important when we think about the pricing model, right? Serverless platforms like clouds, like all cloud services, are kind of pay as you go. You're only supposed to pay for the resources that you use. But now you're only actually using computational resources when you're processing requests. And now you don't have to pay for all of that idle time. And this can lead to some really, really dramatic cost savings. So there was an article in Business Insider last year looking at serverless and the rise of serverless and use cases and customers. And they were talking about one customer who was a cybersecurity firm. I'm clicking too much. It was a cybersecurity firm who had this application which processed logs being generated by the customers, and the traffic was very bursty, right? There'd be loads of logs to process, and then there'd be none. It was hard to kind of predict when they would come in. So they had all these VMs sat there idle, kind of most of the time doing nothing. So they heard about serverless. They rewrote version 2 using AWS Lambda, which is Amazon's kind of serverless offering. And what they found is at the end of the month, when the application had been live, their cloud bill had dropped by 80%. So for them, this was from thousands of dollars a month down to just a few hundred, because now they're only actually paying for those resources when they're actually processing requests. They don't have all these VMs sprawling in the cloud, sat there idle, waiting for data to come in. So enough talking about serverless at like an abstract level. Let's actually kind of show you how to use it. And I want to take you through now actually building a real-life application using a particular serverless platform, and give you the kind of tools and techniques to go away and use one of these platforms yourself. And so to do this, I need an idea, right? I need something to build. And a couple of weeks ago, I had an idea of something I would like to try out. And my idea is about the weather. Right? Something you might not realize about British people, I'm from the UK, is we're kind of obsessed by the weather, right? We love to worry about where it's going to affect our holiday. We obsessively watch the forecasts. If you're ever in a taxi in the UK, you can always talk about the weather with the driver. And someone who travels a lot with work, I also have to check a lot before I go on a trip. Oh, okay, do I need to take my coat and umbrella? Is it T-shirt and shorts? And so working in tech, I was kind of thinking, is there anything I could do to help me? And I know last year especially, one of the big trends was bots, right? People are building bots for everything. Facebook has a really great platform. Microsoft has a whole framework. So I was kind of thinking, could I do something with bots and the weather? And one of the tools I like to use at work is Slack, right? Slack's a great platform, kind of interacting when I'm out on the road and things like that. And actually, Slack's a great platform for building bots if you haven't played with it. It's got some really nice integrations using webhooks that make it really, really easy to do. And it's just a really easy way to get started. So I was kind of thinking, for my idea, right, for the MVP, version 1, right, minimum viable product, could I build a weather bot for Slack that I could ask dynamically for forecasts on demand, maybe it could warn me about bad weather when I'm traveling, and that would be kind of version 1 of my product. And I've heard about this serverless thing, right, and maybe I want to try it out because just an idea. I don't want to manage any servers. I don't want to pay any money. I don't want to worry about scaling if it gets really popular. And it sounds like quite a good fit. It's kind of an event-driven application. So we've got our idea, right? We're going to try and build a kind of weather bot for Slack really quickly. The next thing you need is you need a serverless provider to use. And serverless actually kind of started on Amazon's cloud. So at the end of 2014, we kind of started this whole serverless movement by announcing a service platform called Lambda that some of you might have heard of. And for the past kind of 2 years, it was really only an Amazon thing. But then last year, 2016, I think it was the year of serverless because all of the other big cloud providers kind of got on board. They realized the power of building applications using this new kind of paradigm, and they launched competing solutions, right? So whoever your cloud provider is, whether it's, so Amazon Lambda, Azure has one, and Microsoft called Azure Functions, Google Cloud has one called Google Cloud Functions. We have one called OpenWhisk, which is open source. If you're using Kubernetes, there's lots of shims now on top of Kubernetes to give you a kind of serverless interface like Kubeless and Fission. So whoever you want to use now, right, I can guarantee you for your cloud, they have a serverless solution to play with. And at a kind of abstract level, most of them are quite similar as well. So you can take the knowledge from one and kind of apply it to another. Today, I'm going to look at one called Apache OpenWhisk. This was actually IBM's serverless offering that we announced about 18 months ago and went GA before Christmas, but ours is open source, and it was all up in GitHub. And last year, we decided to kind of donate it to Apache so that other people could use it and kind of get involved. So it's not really IBM OpenWhisk anymore. It's Apache OpenWhisk, and that's the one I'm going to be looking at. But it's important to stress at this point that the techniques that I'm showing you today of how to use a serverless platform are really applicable to any one you choose. If you want to go and use Lambda or Azure Functions or OpenWhisk, it's the same kind of concept. There's not huge differences between the providers. But now you have lots of choice, right? You might be thinking, well, which provider might I like to use? And I think there's a couple of good reasons why I like to use OpenWhisk. The first, obviously, is that it's open source. So obviously, we put all the code up on GitHub when it was announced, and now it's been donated to Apache, so you can go and dig through the Scala code and understand how serverless platforms work under the covers. Because one of the things people are worried about with all cloud services is vendor lock-in. That they're really scared of using some cloud service that is completely proprietary, and if they change pricing model, they turn it off, you're kind of stuck forever. So we think by open sourcing bits of our cloud, then it makes people a bit less worried about kind of using stuff. And I think a cool thing about it being open source is that the team is continuing to develop in the open. So you can go and look at the milestones, see what people are working on. You can, if you run into problems, GitHub issues is there. You can submit a request. And obviously, it's open source, so there's a big community building around it now. So if you want to add features to a serverless platform, then you can do this using Apache OpenWhisk. Now, another cool thing about OpenWhisk is, I think, the runtime support. So serverless platforms, obviously, you don't have to set up or manage any environments yourself, so you're kind of dependent on the provider to provide the runtime that you want to use. And if you look across all the big service providers, there's a couple of key languages that are all seemingly supported, and there's some kind of more interesting ones which are a bit more spotty. So for example, Node.js is like the first-class serverless language, right? It's supported on every service provider out there, normally something like Node v6. In OpenWhisk, it's 6.9. Lambda's just announced v6 as well. So if you want to use Node, you're in luck, right? You can pretty much pick whichever provider you want. Looking kind of other languages, most of the providers also seem to support some version of Java and some version of Python. So on OpenWhisk, it's Java 8, Python 2.7, and Python 3.2. And actually, Java and Python are also really, really popular across all the providers. So Azure Functions and Lambda as well support these. These are the big three, I think, of building serverless applications. Now, where the providers try and differentiate themselves is by adding slightly more interesting runtimes out of the box. So for example, in OpenWhisk, that's Swift. So Swift was a language that was developed, originally it was closed source, it was developed by Apple for building native iOS apps, and then a couple of years ago they open sourced it, and now you can use it for pretty much anything. If you look at the Stack Overflow language rankings, it's getting really, really popular as a language in its own right. There's a web framework, there's a package manager, it's just, it's a really, really cool static language. And OpenWhisk supports Swift out of the box, so you can write Swift functions and deploy them as microservices. And the reason that we did this is because we think that a great use case for serverless is mobile, right? Building mobile backends, mobile APIs. And it means that those developers who are comfortable doing Swift for their kind of native app development can knock up a quick API in the same language without having to learn a load of node frameworks and infrastructure. But by far, I think the best thing about kind of runtime support in OpenWhisk is it's extendable. So actually, any runtime that you can package in a lightweight Docker image, you can actually push directly into the platform and have as your runtime environment. So if you want to use Go or Ruby or Haskell or anything basically, or .NET or something like that, as long as you can wrap it in a super lightweight with some restrictions Docker image, you can push that in and completely customize your runtime, right? If you want to use an older version of Node or a newer one, rather than having to wait for the provider, you can just do that yourself. And I think that's a key differentiator. Almost none of the other providers at the moment let you completely customize the runtime. So we're going to build, as I said, my weatherbot idea, and I've chosen OpenWhisk for some of the reasons we've talked about. The next thing you need to do is obviously you need to write your code, right? Code that might look a little bit like this. And today I'm going to focus on Node.js, JavaScript, because it's the runtime I particularly enjoy, but you can use any of them that any provider supports that we've just talked about. So when you finish your kind of microservice code, right, your functions that you want to deploy, a question you're probably thinking is, okay, so if I don't have to set anything up, I don't have to do any configuration, how does the platform know what to do with my code? Well, for all service providers and for every runtime, all you really have to do to make it compatible is you have to add a tiny little interface to your code that acts as the entry point. So when a request comes in, the environment gets spun up, your code gets spun up, and it's going to call this function basically to pass the parameters in, and you're going to return an object with the results of your computation. So imagine I have this service called myservice.js. It's it could be hundreds of lines long. It can use third-party NPM modules. You have loads of functions. All you have to do to make it compatible for OpenWhisk is you have to add a function, a global function called main, which takes parameters, which is an object, which are your event parameters. You call out to the functions, you do your computation, and then you return an object, and that's going to be the result of the computation. And that's all you have to do. For every runtime, it's the same. There's just a tiny little interface, which is normally a function name or label that you have to add, and then it takes an object and returns an object, and you can do anything you want in the main time. So if you finish you've got some JavaScript code, you've added the interface for OpenWhisk, and then you push it into the platform, OpenWhisk creates what's called an action. And an action is the name we use in OpenWhisk for. I think of it as like a sleeping microservice. It's there, it's waiting to be executed on demand, but it's not running, right? So let's have a look at kind of doing this now. Let me take some code from my laptop, my development environment, and push it to OpenWhisk and have it running as a kind of scalable microservice without really having to think about virtual machines or any of that kind of stuff. So let me mirror my screen. And have a drink. OK. So as I said, right, OpenWhisk is open source. It's an Apache project now. So you can pull down the whole platform and run it in a VM locally if you want to play around with it. You could deploy it yourself to other infrastructure providers. People have done that, run it on Amazon, run it on Google. But I think the easiest way, if you just want to play around with it and get started, is we provide you a hosted OpenWhisk service that you can just sign up for a free account and get to use. And it's the same open source project. It's the same kind of open APIs. Adobe also have a serverless platform now based on OpenWhisk, their second provider. So once you've signed up for an account, right, whoever your OpenWhisk kind of provider is, on Bluemix or someone else, you need to have a way to get your code from your development environment into the cloud. And the way we're going to do this is there's a little command line utility it gives you that allows you just to push source code up and then kind of invoke it and execute it on demand. So it's a little binary install, it's just a command line utility, and then it gives you the properties, your authentication keys to get set up, so it's all encrypted. And I have obviously already done this. So let me go to my terminal. Yeah, there we go, right? So I have a little binary. It's called WSK-Whisk. And this is the little command line utility we're going to use to create my actions, my service functions, and kind of invoke them on demand. So let me walk you through, if I go back, let me walk you through a hello world example to begin with to see the kind of development methodology. So I have a little bit of code here. I can see this is like the world's smallest and most useless microservice. So it's just a single function that's going to provide you with a greeting on demand when it's called an event with your name in. And it's going to return you an object down the bottom, which has a kind of greeting string in it. So if I wanted to run this code as a kind of cloud API or something like that, using OpenWhisk, you can say whisk action create. You give it a name. I give it the source code. You just say there's the file. And then it's listed. I can check it's deployed. It says it's already there. So then I can invoke it, right? So I can say invoke hello name. And it should give me back in the result of the API, right? Here in the bit of the JSON response is the result of that JavaScript code being executed somewhere in the cloud on some node instance somewhere. And I can call it again with a parameter to check that it's not all fake. All right, there we go, hello, James. And now I can invoke this serverless function. I can invoke it like 1,000 times in parallel, and it would just work. I don't have to think about scaling or maintaining node or any of that kind of stuff. And this is the kind of methodology you work through. You write your code, you add the interface, you deploy it, and then you can kind of just invoke it through the API. So let's think about then kind of expanding that and actually build our kind of weatherbot example. And I think weatherbot has kind of 3 different functions. I think I want to be able to trigger it with an event, and that event's going to have an address in, and it needs to take the address, which is a text, and it needs to turn it into a location within the world, like using a geocoding service. It also needs to be able to take that location and go and use some weather API to look up the forecast for the next 24 hours. And then it needs to be able to talk to Slack. I want to be able to post that message into Slack as a message from weatherbot. And to save me having to type everything out, I've actually created some of the code already. So all those 3 kind of separate services I've just talked about, the address lookup, the forecast, the Slack integration, I could have as one monolithic JavaScript file. But I want to follow this microservices approach and keep them separate because I might want to reuse them. And then we'll look at a feature of the platform later to allow us to join them together to actually create the weatherbot service. So the first service is called location to that long. So this is my address lookup. And you can see all it does is it's got a function called main. It's going to pass the address from the text, and it uses a third-party geocoding API to turn that into a latitude and longitude. It uses a third-party JavaScript module to make an async HTTP request, and then when that's available, it returns the latitude and longitude to the user. So let's create our little service now on OpenWhisk. What's it called? Location to that long. Cool. And now I should be able to invoke it. So I need to pass in some parameters, address, and I'll do Amsterdam. And hopefully, there we go, right? There is my little web service now that gives me about latitude and longitude for address that comes in, right? So that's the first bit of weatherbot already up and running, and I can just leave that. Let's have a look at the second one. And this is going to it's going to take a location, and it's going to give me the forecast back. So again, this uses a third-party weather API that I've signed up for the credentials for, username and password. And it does the same thing, right? Makes a HTTP request, looks for the result, passes some JSON out, and returns it to us. So I can say whisk action create, like that. And now I'm going to invoke it. Now this takes a few more parameters. So it takes latitude, which was, what was it for Amsterdam? Like 52.3. A longitude, which was 4.89. And it takes a username and password for my credentials, because I don't want you to see them. and password. Like that. Let's try. Hopefully this will work. Cool, right? So that apparently is the forecast for Amsterdam at the moment, right? I don't understand Fahrenheit. I understand Celsius, so I have to pretend that seems about right. Mixture of sun and clouds. Now, if you're using serverless functions, right, you end up just often you're just calling third-party APIs and services and kind of stitching them together. So you need to manage the credentials for those services. Now, you can pass them in as part of the request, but that's a bit of a pain. So one of the things you can do in OpenWhisk is you can store your credentials with the function and get the platform to pass it in automatically. So I don't want to pass in my username and password every time. So what I'm going to do is I can say update. So now the parameters are stored on the platform, and if I invoke it again, I can get rid, hopefully, of the username and password, just pass in the latitude and longitude, and now the credentials are stored automatically. So we've got the first two bits already up and working, right? Address lookups, forecast lookups. The next thing I want to do is I want to be able to post messages into Slack. So I have this Slack channel here, which I use to talk about the weather. And I want, when it gets triggered off an event, I want WeatherBot to post the forecast into here so I can see what it is when it gets triggered from some external event. And again, we're going to use webhook integration in Slack, which makes this really, really easy. So Slack has something called incoming webhooks, which is an integration you can add into the platform. And what an incoming webhook allows you to do is, says it will give you a unique URL for a channel, and you can post JSON to this URL endpoint, and it will turn up as if it's a message from a bot. So it's a really nice way to, without really doing any configuration, get a way to post messages from bots. So now I need an OpenWhisk action that I can trigger with some text, and is going to make that HTTP request for me. Now, I could do this myself. I can write some JavaScript to be able to do that. But actually, I can use a feature of OpenWhisk called packages to make this even easier. So OpenWhisk comes built in with lots of integration for third-party APIs and systems that mean you have actions already deployed within the system that you can just invoke with some parameters rather than having to write the code yourself. So for example, there's a package for Slack that says I can post to a webhook just by calling this function and giving it some parameters. So let's try it out. So it says it's called Whisk System Slack Post, like that. And I need to give it some text, hello, and some, well, so I need to give it a URL, which I've already stored there, and I need to give it a channel. And hopefully, right, there's a little message posted into that webhook. So rather than often with OpenWhisk, rather than having to write the code yourself, you can just use one of the packages and actions that come built in within the system. Now, I wanted to change like the emoji. It's very important. I wanted a better emoji, and I wanted a better title for my bot. So I've actually taken that default package and kind of bound some different parameters and customized it so that I just have to invoke it with text every time. So I have a little service called webhook that I can invoke with some text, hello, and will come up as if it's a message from my bot. So right, so we've got kind of three components now of WeatherBot up and working. The next thing that I want to do is I want to be able to basically take those three services, and when they're triggered off by an event, I want to call them all in order. So when an address comes in, I want the output to be a message in Slack from my WeatherBot. And again, I could write another serverless function that manually does the invocations and then passes the data in and out. But OpenWhisk has a cool feature called sequences that can actually do this for you. So when you're creating an action, if I list my actions, I can say whisk action create, and I'm going to give it a name, location forecast. And I say it's a sequence, and you just give it the names of the other functions that you want to call in order. So I want to say it's going to call that one, and that one, and that one. And what happens is when I invoke that serverless function now, whisk action invoke location forecast, I have to pass in an address, which is the input to the first function in that sequence. And it should invoke them all in order, and then hopefully the output should be, where's that? Right, there we go. Right, there's the forecast for Amsterdam in the channel. So often using things like sequence in OpenWhisk, you can get rid of a lot of boilerplate code of just joining different services together. So cool, right, we're kind of almost about halfway. There's only a couple more things to finish off. And let me just jump back to the slides and kind of explain how you might integrate your serverless functions into your application when you've actually built your APIs. Cool. So yeah, so once you've got your serverless functions deployed, as we've just talked about, how can you call them from other applications? And the first way is really easily through the platform API. So OpenWhisk has a REST API for the entire platform that you can use to upload new code, deploy new actions, to invoke it, to get the results of the computation out. And any application you can make a HTTP post request to, you can invoke your functions on demand. Now, with the platform API, it's authenticated in that it uses your developer credentials, your authentication key that you've signed up for. It's kind of got full privileges. So if you want to build like public APIs or public endpoints, obviously you can't embed those credentials in some client-side JavaScript without exposing it to the world. So what the kind of pattern in service development for how to manage this is to use a third-party cloud service like an API gateway. So all big cloud providers have these services, and what they allow you to do is create public APIs that then proxy private APIs in the back end and keep your credentials secret. Amazon has one called API Gateway. We have one called API Connect. Google's just acquired Apigee to be able to do this. So every big cloud provider has this kind of public API service. And you connect them to your serverless functions to create your kind of public API endpoints. So that works really well for kind of direct invocation where you want to send a request and wait and block on the data coming back, right? And manually invoke that in your code. But what about kind of asynchronous processing, right? Because again, one of the big use cases people talk about for serverless is having your serverless functions run automatically whenever a message comes on a queue, a database gets updated, there's a new file in your object store to do that kind of asynchronous background processing without you having to manually trigger it off. Well, in OpenWhisk, we handle this through something we call triggers. So in OpenWhisk, you can create a trigger which listens to one of these external event sources, whether it's a webhook, whether it's Kafka, whether it's CouchDB or something like that. And whenever that external event source fires, the trigger fires an OpenWhisk, and then you can bind your triggers to your actions using a rule. So you can say whenever a message comes on a queue, your trigger fires an OpenWhisk, and then it automatically kicks off your action. So you can use this for doing all kinds of asynchronous processing. And there's tons and tons of event sources. So rather than you having to manually kind of poll an event source and invoke the functions on demand, you can connect them up to run automatically. So let's go back quickly and kind of finish off Weatherbot using the first approach of the direct invocation using an API gateway and kind of finish it off. So to finish off, what I want to do is, so I've got a way to trigger my Weatherbot and have it post the messages into Slack, but I want to kind of trigger it directly, right? I want to be able to say, give me the weather for Amsterdam, and I want it to run the functions and respond automatically. Thank you. So that's better. Yeah, so what I want to be able to do is I want to invoke it directly, right? I want to be able to ask it questions and have it respond and run the functions. And again, the way we do this in Slack is using what's called an outgoing webhook. So Slack has outgoing webhooks, and what this allows you to do is say whenever someone in a particular channel types a particular trigger word at the beginning prefix, I want you to call a URL that I give you, right? So it's going to post the JSON for that message to an external URL that you can give it. So with OpenWhisk, right, what we're going to do is we're going to create an external API that I can then post into the webhook box, and then it will be triggered, and then I'll get my forecast back on demand. So again, I can come into kind of Bluemix console and use the API gateway to do this. So I can say, create me a little API. I'll give it a name. Let's say it's called Weatherbot. That's a base path. Let's create an operation. So it has to be, let's say, forecast. It's got to be a post. Like that. It will say, OK, what do you want to call? And I want to call my serverless function. I click Save. I come down to the bottom, click Save. And this is going to create me my public API endpoint that I can use. It's going to call my serverless function on demand without exposing my keys to the world. So now if I go to API Explorer, it should give me my endpoint. I can post that into the box, and then it should work. Cool, right? So it's a bit fiddly to copy. Do that. Now if I post my URL in there, I click Save. Hopefully, fingers crossed, a lot of moving parts. Now if I send that message, it doesn't work. No, it does work. It does work. Woof! OK. Woof. OK, it all works perfectly. So, and to show it's not fake, right, I can say, like, weather New York or, like, weather London, probably raining. Yeah, probably raining. Yeah, can't wait to go home. And you can see, right, so using the API gateway approach, right, it makes it super easy to create public endpoints for serverless functions and build APIs and microservices in the cloud really, really easy. So within, like 15 minutes or whatever, I've actually been kind of typing, I've got some code from my laptop running in the cloud as a bot that I could then, thousands of people could use. I don't need to think about it. You've not seen me touch a VM. And all that kind of stuff. And hopefully I've kind of tried to show you why I'm so excited about serverless, right? I think it's really, really revolutionary, and it makes it really, really easy to get ideas into production. So I said at the start of this talk, right, that servers are killing your productivity. And hopefully now you agree with me, right? All that time spent patching kernels and managing VMs and fiddling with upgrading middleware versions is time that you're not really spending on building your products, right? And writing codes, fixing bugs, listening to users, getting out version 2. And I think as software developers, we are held hostage by our infrastructure, right? We want to spend time writing code, and I spend time actually logging into some Linux VM to fiddle around with some kernel parameters. So I want to kind of encourage everyone here, right? If you're building modern applications for the cloud, kind of modern cloud-native architectures, think about embracing the serverless revolution, right? Burn your servers, deprovision your virtual machines, be free of the tyranny of looking after infrastructure forever, right? Once you go serverless, you never want to go back. But more importantly, kind of upgrade your productivity, right? Stop spending your time managing these cloud VMs as a service, right? And get back to actually writing code. So thank you very much for listening. If you want any of the resources from this talk, if you go to the bit.ly link, then there's a GitHub repo with everything in, like the demo code and the transcripts and the videos that you can walk through building WeatherBot yourself. If you want to get involved in OpenWhisk and you need some help, come join us in Slack, because we've got a kind of growing community around there, which is pretty awesome. And you can talk to developers, you can talk to me. Stack Overflow is a thing. We're on there answering questions. And then also, if you need a more kind of personal introduction, then you can find me on Twitter, or you can tweet OpenWhisk, and someone will come and help you. But yeah, go forth, build service applications. Don't worry about infrastructure anymore. Thank you.
Now? How about that? Okay. Thanks for your talk. Great talk, great topic and delivery. My question is, if I decide to use OpenWhisk, it's clear that IBM supports it, so I guess the billing would be on demand. But what if I need to use, for example, Amazon, AWS or something? How does the billing would work in that scenario? Or you should support it natively, or what?
So all of the serverless providers they kind of bill you per 100 milliseconds of execution time. So if you're using a hosted one, then it's handled by the provider. If you want to deploy it yourself, then it would be a more traditional billing model of managing that yourself. But yeah, I think that for all of the hosted providers, so Amazon, IBM, everyone these days, they bill you per 100 milliseconds of execution time, and it's the way it works is that you can choose how much memory your function gets to run in, and it's like gigabyte hours, basically. That's how it does, down to millisecond billing, basically. So you only pay for you don't pay for anything else apart from the gigabyte seconds per 100 milliseconds of time.
But if I want to use OpenWhisk at Amazon?
Then you're paying for the VMs under it.
Then it's a traditional billing model. So I should either look for a platform that supports OpenWhisk, like IBM, or just go with the native Lambda functions on Amazon, right?
Yeah, I mean, that's what I think. Some people think, well, what's the point of serverless? It's open source. There's some benefits in terms of for testing. It's something I didn't get onto, but system testing is quite hard with serverless functions because it's not your environment. How do you simulate all your services running in parallel? And with an open source platform, you can actually spin OpenWhisk up in a VM locally to kind of do more realistic system testing and things like that. Adobe have also just launched a serverless platform based on OpenWhisk, so you do have 2 providers to be able to choose from. But yeah, my recommendation really would be just use a hosted one, whoever you choose, and let them do everything for you. That's kind of the point of it, really.
Right. Thanks again.
Hi. All these, these lambdas are stateless, I guess, yeah?
Yeah, you have to be. They have to be they have to be stateless because they get killed after every request. Now that's not technically true. What happens is you get about 5 minutes. So if another request comes in afterwards, you get what they call a warm container. You get a warm one, so you can use it to store some state between requests, but you can't really rely on it. So yeah, but generally they have to be stateless. It's how it scales horizontally. It doesn't scale vertically. So yeah, in general they have to be stateless.
So basically, a microservice, as probably maybe I had from how I see it on how you explain it, it will be either a sequence of these actions that you define, or I don't know, maybe sequence or parallel. For example, action if this go to another action, otherwise go to another one. Maybe like scenario of actions.
Yeah.
And so there's no way to keep a state among all these.
Yeah. So that's a good question. The orchestration side of it is just kind of being worked out at the moment. So for example, Amazon has a service called step functions, which allows you to do state-based like execution. So say, call this service if the result is this, and the other providers are also looking at this. So it's one of the things, because serverless is still very new as a space, and that kind of state-based execution is something I think they're all going to add this year. But yeah, at the moment, there's not really a great solution for doing that.
Okay, thanks.
Yeah.
So isn't it misleading to call this solution serverless? Because apparently you do have a server, only you don't pay when you don't use it. But then you have a server.
It's just a name. It's just good marketing term, because then everyone gets very angry about it and says, oh my God, how can you call it serverless? There's still servers. Oh, but yeah, there's still servers. You know, don't worry about it. You know, yeah, I mean, there is still going to be a server. Your code doesn't run in the cloud in the actual sky, but you have no interaction with it. So that's where they work. I mean, people also will call it functions as a service. So if you think that's a better name, I like serverless, and it gets people very mad, and then they talk on Twitter a lot. So I think it's a very good marketing term.
Are the tools available for larger deployment? So if you have a more complex system.
Yeah. So that's, as you're building bigger applications, again, this is a slightly shorter talk than I normally do, so I didn't get to talk about some of the challenges of serverless, because it's not perfect. There is lots of wicked open source frameworks for helping you. So I think the best one to use is called the Serverless framework. It's really popular. It's got like 1,000 million stars on GitHub, and it allows you to have all your application like services in a YAML file, and you just type serverless deploy, and then it does everything, and you can roll things back. And it's just great, and it's open source, and it supports now all of the big providers. So you can use the same open source framework with Lambda, with Azure Functions, with OpenWhisk, and with Google Cloud. So it's a really cool. So yeah, once you get beyond the hello world stage, you start to enter, okay, how do I deploy like 12 functions in one go? And that's where the tooling can kind of help you. So yeah, there's lots of stuff for that at the moment, but it just didn't get time to show it all today. Cool. I think I'm not allowed to answer any more questions, so I'll be around now or all day, so just come and hang out and chat to me. Thank you.